Lesson 4.6 is going to look at another type of measurement to help us interpret data. So the previous lesson we did measures of central tendency or measures of average. We're now going to look at measures of variation. And there's a couple other words we can use for this. So measures of variation are often called measures of spread. And so it's looking at like how spread out are our data. I think that might be a little clearer than variation. And one of those measures, we're actually only going to look at two measures. One of them is standard deviation. It's kind of an annoying calculation. And then the other one is variance. These two are very closely connected. And there's one other measure. Actually, there's two other measures I'm forgetting here. We're going to look at range. And the final one, it comes in two names. It's the relative standard deviation, also known as the coefficient of variation. Don't confuse that with the coefficient of determination or the correlation coefficient. So these are the four types of measurements we're going to look at in this section, and that will help us understand the idea of spread. Range is a really simple, quick calculation. It's not a very good measurement of spread. It's just take the largest value and subtract from it the smallest value. Notice this is really similar to the mid-range function, which was the sum of these two numbers divided by 2. So let's look at some data. These pictures on this previous page are two sets of dogs. I think that there's 4 dogs here and a bunch of dogs here, and we're wanting to look at what's the variation of these pictures of dogs in terms of how much they weigh. So here's the actual weights of the two dogs, and we're going to find the range for each of them. So for the first picture, what's the largest number in there? It's 73. What's the smallest number? It's 58. And 73 minus 58 looks something like 15. So there's 15-pound difference between the top dog, the top weighing dog, and the bottom weighing dog. Then we look at the range for the second picture. And so the largest number there is 125, and the smallest number there looks like 30. And 125 minus 30 appears to be 95. So there's a big difference in ranges of weights of these two dogs. Let's quick calculate the means. This is a great review. So I'm just going to type the word mean and then put in the numbers 70, 73, 58, 60, and there's the mean weight for the first set of dogs. And for the second set, I'll do the same thing, type mean and type in those numbers. Doesn't matter the order you type them in. You do have to put them in commas if you're going to use this mean function. Otherwise, you could do the formula itself. Add all these numbers together, divide by how many. So this one gets us a mean of 64. Looking at just the measurements of means, the two sets of dogs appear to be very similar in terms of their center, but they're really spread out in terms of the types of weights we see amongst the dogs. Note, remember in our prior section, 4.4, the mean was only a good measurement of the center if there were no outliers in the data set. Otherwise, we use the median as the measure of center. So looking at this, the calculation of range, we are using potential outliers to calculate the range, so it's probably not a very good measure of variation when outliers are present.